You don't have to take notes today, I guess, actually, if you want to just watch, as long as you're going to watch and participate, so we can fly through. And you're not just not watching. If I see people playing with their phones, I'm going to have a freak out. We'll have a pop quiz, which I have a few that are ready to go. Okay, is the function periodic? What's the period? Guys, it's been a long time. You're going to see this. It's a huge part of the secondary 3 core. Periodic function. So it says, is this function periodic? What's the period? What's the amplitude? So looking at it, guys, it's really hard for me to draw it exact because I'm freehanding it. But I'm telling you, this pattern repeats the same, okay? So we'll call this, yes, periodic. So we'd say it's periodic. That's because our intervals repeat the same. The intervals repeat the same. So we call this, yes, periodic. However, if it's all over the place and there's no repeated pattern, you'd say not periodic. So it says, what's the period? You guys, we've got to get this in our head because a lot of us get confused with period and number of cycles. So period means physical length of one cycle. The physical length of one cycle. So looking at this, like I said, it's hard for me to rough sketch it. Roughly one cycle, if I started at 0, it goes up, bump, bump, down, and then doesn't this where it starts again, roughly? Up, bump, bump, down, up. So we'd say the period, the physical length of one cycle is 4. Is everybody comfortable with that? Make sense? Okay, and then it said, what is the amplitude? We got to be careful with the amplitude on this one because it's not on an even interval. -3 to 5, what's the total distance here? 8. So that divided by 2 is 4. So our amplitude is 4. Questions on that? Okay, next problem. It says, what is 60 degrees in radians? This would be such an easy problem that if you missed it on your final exam, I've seen this on a few people's final exam. It is such an easy one. If you miss it, you are just a blasted idiot. So what is 60 degrees in radians? Remember, to go from degrees to radians, didn't we say radians second? So we multiply the degrees by pi over 180, because that's just a fancy one. Isn't that 1 pi is halfway around the circle, right? Isn't that 180 degrees? So we multiply by pi over 180, and I'll put it in terms of pi, which would be radians. This is the physical distance, radians is. Degrees and radians are equal, just one's a physical distance, one's the degree measure. So it says, what's 60 degrees in radians? We'll take 60 degrees times by pi over 180. You will not type pi into your calculator. Do 60 divided by 180. You're right. That becomes a 1, that becomes a 3, right? So that's pi thirds. So if I said to you, or on your final exam, it said, what's pi thirds in degrees? What you do is say, I'm going from radians to degrees, right? Radians to degrees. What did I say second? Degrees. So I would have put the degrees on top and the pi on bottom. Then your pi would divide out. I'm just showing you how to go backwards. Becomes 1s, and that becomes 60 over 1. Does everybody see how that becomes 60 degrees? You've got to be able to go back and forth. Such an easy one. Don't miss it. Okay, it says, what is the exact value of sine of -45 degrees? Your calculator will not give it to you. Therefore, you have to have a unit circle filled out. So on your stage, the first thing I'm going to do is I'm going to have a blank unit circle there for you. So that's not cheating because it's blank, right? So then you can fill out your unit circle. That's the first thing you should do when you sit down and take your stage. Does everybody understand what I'm saying? Okay, so let's practice filling out the unit circle. It's got to be blank or else I'm cheating and I'm not a cheater. So it's got to be completely blank. Let's remember how to fill it out. There's a lot of tricks. Pay attention because we're going to practice this in a minute. If you can't fill out a unit circle, you can't get any of these problems right, and they're really the easiest ones on your test because it's just looking with your eyeballs. Because everybody will remember, doing this. So isn't this 0 degrees? Let's fill in our degrees first. 0 degrees. Then remember, there's a pattern. You go up 30, 15, 15, 30. Okay, 30, 15, 15, 30. So up 30 degrees, right? Yeah. Let's all have our calculators handy so I can fly through this, okay? Because it takes me more time. I want to just write. So you add 15, 45. Add 15, you get, add 30, you get 90. Add 30, you get 120. 135. And 180. Okay? 30. Add 15. Add 15. You guys can add better than me. Add 30. Add 30. Add 15. Add 15. And add 30. 0 degrees and 360 degrees. So we know we've ended up right, everybody, right? So we know we've done it right. Okay, now I'm not going to convert, well, yeah, you know, we might want to, but we might not care that much right now. Couldn't we convert all those to radians? Because they might say, and we won't do that right now, but they might say, what is the sine of pi half? So you'd have to know where pi half is, right? Which if you had these converted to radians, that's 90 degrees. Does that make sense? But you'd only do that if you needed to. So we'll do that in a second if we need to. Now filling in the outside is the next thing you have to remember. Think about it. A unit circle has a radius of 1. So if this is a radius of 1, and we go out to this first point, these are what you'll fill in first. Isn't that over 1 up 0?
Yeah.
This is over 0 up 1, right? Negative 1 up 0, right? And down 0, negative 1. Is everybody comfortable with that? So then from there, filling in quadrant 1 really easy. You start at 0. That's the square root of 0 over 2. It's just a pattern you've got to have memorized. The square root of 0 over 2 is 0, right? So then you count up. The square root of 1 over 2. Right? Everybody?
Yep.
The square root of 2 over 2. The square root of 3 over 2. And the square root of 4 over 2. Which is, the square root of 4 over 2 is 2 over 2, right? That's where our 1 comes in. Let's count backwards like the other way. So this square root of 0 over 2, so this must be the square root of 1 over 2. Can I just put 1/2? The square root of 1 is 1. The square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2, which is 1. So I'm just going to fix this to be just 1/2 instead of square root of 1 over 2. Now, guys, if you do that this way, it works the same way. So this is 0, right? And this is x is, right? 0. So this would be the square root of 1 over 2, right? Right? And they match up with the points, right? Does everybody see how to do this? So 1 over 2, then square root of 2 over 2. So this is the square root of 2 over 2, right? So then square root of 3 over 2, square root of 4 over 2. So this is 1 over 2. This is square root of 3 over 2. Now we've got to change our signs for this. This is quadrant 1, right? Aren't all x points and y points that fall in quadrant 1 positive? So x and y's are positive. Now look, quadrant 2 has negative x's, positive y's if it falls up here, right? Negative x's, positive y's. So we'll just change our x's to be negative. Does everybody see how to fill this out? Okay, we're all good. I'm not going to keep going then. Okay, so let's answer the question. There's the unit circle all completely filled out. What is the exact value of sine of negative 45? Can we go positive direction and negative direction? Yeah, on the unit circle. So we're going to look at this unit circle. Positive 45 is going up 2 tick marks, right? Let's go in the negative direction, negative 2 tick marks. Sine is, you've got to remember this, cosine is x, sine is y. Okay? So it says what's sine of negative 45 degrees? So we're right here, right? Sine is y. So our answer would be negative square root of 2 over 2. Wouldn't that be such an, it's easy in a sense to miss, right? It'd be hard to, that's the easy one. Let's not miss it. Does everybody understand how to do it? Yes or no?
Yes.
So negative square root of 2 over 2 would be my final answer. Okay. Next problem. What is 2 angles where cosine is the square root of 2 over 2? So cosine is x, right? So it wants to know what 2 angles have an x value of square root of 2 over 2. So you'd use your unit circle again. Let's look at it. Right here, isn't this x is square root of 2 over 2? So 45 degrees is where cosine is, square root of 2 over 2. Now, don't miss it. It said what 2 angles, because that makes sense. Isn't there another positive x, square root of 2 over 2? And that was at 315 degrees, right? So our answer would be 45 degrees or 315 degrees. So 45 degrees and 315 degrees. Questions?
Yes.
Yes. I think that would actually be acceptable, yeah. Yeah, right? So that's negative 45 degrees as well, right? I think they would say, and if they did not want you to do negatives, if they didn't specify, that'd be fine. If they said what are 2 positive, you'd go with these, right? But if they didn't specify, yeah, I think these answers would be absolutely acceptable. Questions? Okay, it says, if sine of theta is equal to negative square root of 2 over 2, what's the possible value of theta in radians? So aren't we just looking for when does our angle theta equal the square root of 2 over 2? Right? And it's sine, right? So isn't that x values? Nope, that's y, right? Y values? So it says, what value of theta, if sine of theta is equal to negative square root of 2, what's the possible values of theta in radians? So let's look at our unit circle again. It was at negative square root of 2 over 2? Yeah. Okay. So y values. So I'm going to erase this. Okay, we're at our fresh unit circle here. Let's find the y values that equal negative square root of 2 over 2. Right there? Right there, right? So what? It's 225 degrees and 315 degrees, right? But didn't it say what value of theta in radians? Right? In radians, so you would then convert those to radians, wouldn't you? Isn't the answer 225 degrees in degrees? And 315 in degrees. So that's how we'd answer it. We'd say, oh, sorry, I already forgot. 225 and 315. So that would be our answer. We'd say to ourselves, we wouldn't type this in yet, 225 and 315. Since you want it in radians, we'll multiply by pi over 180. Pi over 180, you'll simplify it, right? And then our unit circle had it simplified too. 5 pi fourths and 7 pi fourths. So this simplified to be 5 pi fourths, 7 pi fourths. Also an easy one, don't miss these. Okay, what are two positive and two negative possible coterminal angles with 135 degrees? So guys, coterminal means sits in the same spot on the unit circle. So, and it was 135 degrees, right? I want to make this make sense for you so you don't have to memorize any formulas or anything. So it was, sorry, what was it, 135? Guys? So it's saying what angle, what positive coterminal angle is equal to that, really is what it means. It wants it to fall in the same spot. So think about it. If we were at 315 degrees and we went around in the positive direction, a full circle would not just be adding 360. Another positive would be adding another 360. Can't we go around the unit circle as many times as we want? So a negative coterminal angle would be going backwards. Let's take 135 and let's go backwards. So let's subtract 360, right? We'll end up back in the same spot. That's what coterminal means. This would be a dumb one to miss. Okay. So you take your theta, 135, and you can add 360 as many times as you want, and you can subtract 360. Now here's where people get mixed up. They'll take 360 and subtract 135. But think about it. Say I'm starting at 135 and I want to go around a circle. So you'd start with 135 and add 360 to it. Does that make sense, everybody? So we need two positives, so I'm going to add 360 twice. And then we need two negatives, so I'm going to subtract 360. And I'm going to subtract 360 again. Does everybody see what I'm doing here? Yes or no? Because I'm kind of writing it weird, I get that. Are we all good? I'm not going to calculate these. If you get what you're doing, we're good. Okay. What's the amplitude and the period of the function? Oh my heck, we really need to get this in our head straight because I'm not going to blame you. I used to get it mixed up really bad too, so we've got to be careful. So you need to say to yourself, and in fact, when I write down my unit circle, I make sure to always write cosine x, sine is y, and then I write down the equation of a sine and cosine function in general. So this is cosine. Y is equal to a times cosine of b theta. And then I write out what each thing means. A is the amplitude, so I don't get mixed up. B is not the period, guys. B is not the period. A lot of you are going to say that. Don't say it. B is the number of cycles. You've got to get this in your head. From 0 to 2 pi. Okay? Is everybody going to say okay? Ready? Okay. Okay. But we do know how to calculate period. Period is 2 pi divided by b. So now let's answer that. That's the first things I write down on a blank test when I go in to take any tests. So it says, what is the amplitude? What is the amplitude, guys? 3. And I think we would, because the amplitude is simply 3, right? The negative reflects it over x, but I did notice on the stage review packet that they call the amplitude -3. So just keep that in mind. It is an amplitude of 3, right? But it is a reflection over x because of the negative. But I just noticed that in your packet. Okay, so amplitude, we'll call it -3. Then it says the period, we're asked to find the period, right? So there's 2 cycles from 0 to 2 pi, so our period is the physical length of a cycle. We know it's this formula. 2 pi divided by b is 2, so what's our period? Pi, so that's how we answer it. Period is pi, and then amplitude was -3. Okay, next one. How many cycles are from 0 to 2 pi if you have an amplitude of 3 and a period of 6 pi? So you've got to be able to work backwards. So guys, think about it. Isn't the formula for periods equal to 2 pi divided by b? Right? So it says, how many cycles are from 0 to 2 pi if the period is 6 pi? So wouldn't we just plug in what we know, solve for what we don't? B stands for number of cycles, right? Is everybody paying attention? This is for your benefit. So we have 6 pi is equal to 2 pi over b. This is where a lot of people royally mess it up. Solving for b, wouldn't we cross multiply by b? But the b's divide out. Now to get b alone, what would you do? Divide by 6 pi. So b is 1 over 3. Those divide out to be 1. Our b value is 1/3, right? So the number of cycles from 0 to 2 pi is 1/3 of a cycle. Okay, now we can write the equation for the sine function. So we have y is equal to our amplitude 3. So 3 sine of, it's b theta, not period theta. So sine of 1/3 theta, right? Questions? Okay. Last one. Write the function of the sine if the function has been translated 5 units up and a phase shift of 3 units and has a period of 4 pi. So I say to myself, a non-shifted sine function looks like this. Y is equal to a times sine of b theta, right? Okay, a shifted looks like this. Y is equal to a sine of b theta minus h, right? This is our shift left and right, plus k. So let's put in what we know. The amplitude is, does it say? Okay, so our amplitude's 1, we'll go with. So y is equal to 1 sine of, b is the number of cycles, weren't we given the period? So can we put in 4 pi right here? No, right? B stands for number of cycles. So we'd say, okay, we're given the periods, we know a period is 2 pi over b, we're given the periods 4 pi. So instead of p, we'll put 4 pi. So when we multiply by b, guys, divide by 4, so isn't that 1/2?
Yeah.
So sine of 1/2 theta. Now we're shifting 5 units up and a phase shift of 3. A phase shift is a shift left and right. So a phase shift of 3 units, I should have said right. A phase shift of 3 units right. So wouldn't we do minus sign? Did you go opposite of what's shift left and right? So it'll be, if it was right, minus 3. And then we'll put a parentheses around that, and then plus 5. Good. We're all good? Good review? Okay, do up to pages 55. Go. You should be caught up. Up to page 55.